So this is the last video for the chapter on respiration. What we're going to look at in this video is the total number of ATP that are produced from one glucose molecule. So it's kind of fitting that we finish where we started, going back to this original diagram and looking at the different numbers of ATP produced in each step. The first thing to do is just look at glycolysis, and we'll work our way through the process. If you remember when we were talking about the process of glycolysis using the diagram on the board, we said that glycolysis produces a net value of 2 ATP molecules. So it takes 2 ATP to get the process started. We get 4 back in the end, so we're overall getting 2 net ATPs from that process. From the Krebs cycle, if you remember, each pyruvic acid that goes through there produces 1 ATP. So altogether, since there are 2 pyruvic acids from glycolysis, we get 2 ATP directly from the Krebs cycle as well. Now, the last number is where things start to get a little ridiculous. From electron transport chain, we're getting a total of 32 ATP. Now, most of those ATP are coming from the electron carriers NADH and FADH2. So even though it looks like the vast majority of the energy is made at the end of this process, and technically it is, the first 2 processes are what set all of that up. That's where the NADH and the FADH2 is being produced. It's being made either in glycolysis or in the Krebs cycle. Your book gives a pretty good diagram that helps to break down this process. We are going to come back to that first image in a second. But this is straight out of your textbook, and I like this for the most part because it helps you understand where some of these ATPs are coming from. For starters, this gives you the total number. We're going to sort of start at the end and then work our way back. You get 36 total ATP from one glucose molecule. Now, to go back and break down where those come from, we're going to start with the products from the Krebs cycle and sort of work our way back through the process, because I think that's the easiest way to go about it. If you look at the 2 FADH2 that are made during Krebs cycle, and keep in mind, all of these values we're talking about are for 2 pyruvic acids, because there's 2 pyruvic acids created in glucose. So it'll be double the value of all of the numbers we were talking about on the board in class, since in class we only went through the Krebs cycle once. But if you remember in class, we made 1 FADH2, so now we're making 2, since we're going through the process twice. FADH2 joins in the second step of electron transport chain, which means it gives us 2 ATP each. So the number here is 4 total ATP for those FADH2. So the easy way to think about this is that these guys are worth 2 ATP each. NADH, on the other hand, joins in the first part of electron transport chain. So that's worth 3 ATP each. So if we have 6 NADH times 3, that gives us the 18 ATP that we're getting at the end of that process. The 2 ATP here are the ATP that are made directly during the Krebs cycle. So if we go back to this one that we were looking at before, that's where it represents those 2 ATP down here, made in the Krebs cycle. That's the same as the 2 ATP that are represented there. And then moving back up, there is some NADH that's created in the beginning of the Krebs cycle before we actually get into the cycle portion itself. Remember, when that very first carbon is removed from pyruvic acid, the energy that's used to break off that bond is used to energize NADH. And so that NADH, just like the other ones, eventually makes 3 ATP. So we've got our 2 NADH molecules times 3 ATP each gives us 6 ATP. The rules get a little bit more complicated once we leave the mitochondria. Now, if you remember from the process of glycolysis, move this one over so we can pull this back up again. The process of glycolysis gives us 2 ATP directly. Those 2 are represented here. The other thing that we get from glycolysis is NADH. If you remember, it shows it going up and around and over to the electron transport chain. Here's where the rules start to get a little funny. I said earlier that NADH is worth 3 ATP each, here and here. That's only if it's inside the mitochondria. NADH that's outside the mitochondria is technically only worth 2 ATP once it gets to electron transport chain. The reason is that it has to be transported all the way over and into the mitochondria, and it takes energy to do that. So even though it technically still gives us 3 ATP molecules, it's 2 net ATP. And that's really what we're looking at in this process. We're looking at the net value of what we're getting. So because of that, because those NADH have to be transported into the mitochondria, as opposed to the ones that are coming from the Krebs cycle and are already inside the mitochondria, we get less energy from those. Since there are 2 NADH created there, 2 times 2 gives us our 4. So if you add all of these up, the 4 ATP that we get from the 2 NADH from glycolysis, the 2 net ATP made directly in glycolysis, the 6 ATP that come from the NADH made before we get into the cycle of the Krebs cycle. These are the NADH that come directly from the pyruvic acid. And then you've got the 2 ATP made directly in the Krebs cycle, the 6 NADH that are worth 3 ATP each, giving us a total of 18, and then the 2 FADH2, which are worth 2 ATP each, giving us a total of 4. If you add up all of these numbers, you end up with 36 total ATP. As far as the rules go, I think it's simplest if you think of NADH as being worth 3, FADH2 as being worth 2, and then you just have to remember that the NADH that's made in glycolysis is really only worth 2 net ATP, since it has to be transported over and into the electron transport chain. Just to give you a couple of important things to remember, some important points, FADH2 equals 2 ATP. And remember, this is once it gets to the electron transport chain, where these things are then converted into energy. NADH is going to differ. The NADH from Krebs is worth 3 ATP. The NADH from glycolysis is worth 2 ATP, because it has to be transported inside of the mitochondria in order to be converted into energy. All of the other ATP in this process is made directly in the other steps. So that's the stuff we were seeing that's made directly in glycolysis, and some of it that's made directly in the Krebs cycle. One final thing that's good to know, if we go back to the other one. So the final thing that's good to know is that how many are made in each step. Technically we get 2 from glycolysis, 2 from the Krebs cycle, and then 32 from the electron transport chain. So as always, I appreciate you taking the time to watch this, and if you could just make sure you answer the questions when the video's over. This is the last one for the chapter. Thank you for watching.